All right. Good afternoon, everybody. My name is Laura Wisse, and I will be talking about T2-ASHS quality control, or QC. And I'll actually be only focusing on the 3T atlases. And before I start, I wanted to thank Sandy, Emily, and Annika for helping me put together all the examples in this talk. So ASHS again stands for automated segmentation of hippocampal subfields, but it's actually grown beyond that and also includes segmentation of pericampal gyrus subregions. And the original T2-ASHS method was published in the paper on the left. And recently we made a new one available based on a newer protocol by Baron et al. And that one is presented in the paper that you can see on the right. So here are some resources. So both the PMC, so that's the older T2-ASHS pipeline, and the newer, we just call it ABC T2-ASHS pipeline, are publicly available now. And of course, there are some other tutorials on YouTube on my channel, which can potentially also help when you're doing QC. And then throughout this tutorial, I'll be using ITK Snap to show different images and segmentations, and that's of course also publicly available. All right, so then wanted to start with the general process of QCing T2-ASHS, and this is actually very similar to T1-ASHS. So I would start with QC of the MRI, because if the MRI is not good, there's really no point in checking the automated segmentation. So yeah, you can either exclude or then continue with QCing ASHS. Then for most instances, I would recommend starting with QCing the screenshots that are automatically generated if you run ASHS. Then if they're not good, you exclude. If they're great, you include. But it's actually quite often the case that you see something kind of weird or off that you want to check further. So you're maybe not certain if you want to include or exclude. So then I would recommend just opening the image and the segmentation in ITK Snap and going through it. Then again, of course, you can exclude or include if it looks good. And there's then, of course, the option to edit if you feel like you want to keep that subject. It really depends on your study question. So then you can edit in ITK Snap, and generally then you would include, although it happens from time to time that you edit and then it's not possible to edit, and then you have to exclude, of course. So for each of these steps, you can decide per hemisphere, or even per subregion. So what you can do, for example, for one subject is keep everything except the left subiculum, for example. So that's a possibility, of course. And from step 2 to 4 continues to be more fine-grained QC. You can also decide for your particular study to stop after the QC of the screenshots, but then you would have to, of course, make a decision to include or exclude based on those. And then step 3 and 4, I guess, really depends on the sample size, how unique your data set is, potential bias and segmentation error, and so on. And I actually recently got asked the question what to do with even larger data sets of thousands of cases, and I have not made up my mind yet. I'm not 100% sure, but I think I would at least recommend to look at a subset of the data so you get a sense of data quality, type of errors, and potential bias in the errors. So yeah, at least always look at a subset of your data. So before you start QC, familiarize yourself with the data, so you get familiar with the quality, with some of the smaller errors and so on. I would recommend deciding on rules for in or exclusion beforehand, such as if there's a significant error in a label on a certain number of slices, that would be a way in which you can consistently between cases exclude with the same amount of error. And if you're doing QC with multiple people to improve between data reliability, it can be good to maybe go first over a number of cases together, then maybe do 30 cases separate from each other, then look to see how similar you were and discuss differences. And then you can, of course, do the full QC. It can also be helpful then to discuss the difficult cases together at the end, and then just do it by consensus based. And I would in general recommend to note down things you observe during the QC of the MRI or segmentation, because you actually never know when it comes in useful to have those things written down maybe during your analyses, you notice something, and then your notes can really help there. All right, so again, this is also similar to T1-ASHS. There are different files that you can select. Use gray is only used when the atlas set comes from the target data set. In all other cases, we use no gray. For the T1-ASHS, we said it could be useful to look at heuristic. I've never actually done that for the T2-ASHS, but again, it might be good to just check and see what that looks like. So then I want to start with QC of the T2 MRI. So very simple, the rule of thumb is you need to be able to see the boundaries that you need for segmentation. So which boundaries are those? So first are the boundaries of the full hippocampus, the cortex with surrounding tissues, which is mostly white matter and cerebrospinal fluid. And with the arrows here, I indicate the borders with the surrounding tissues. And then what's very specific for the T2 MRI is that it has this high in-plane resolution, which allows you to see this hypo-intense or dark band, also called SRLM, within the hippocampus. And that's really crucial to segment your subfields. So if you're QCing your images, you want to make sure that this dark band is also visible. So here I show you two MRI scans, just to give you two examples. With the zoom in of the left MTL. And I hope you can agree that on the left, you can see all the borders that you need, but not on the right. It's very fuzzy. You cannot really see a lot. So I would keep the left and exclude the right. So now I want to show a few examples. All right. I hope you can still see, you can now see the ITK snap window. Is that correct?
Yes.
Okay, thank you. Thank you. All right, so just to give you an idea what I would be looking at. So for this image, I'm just going for this hemisphere now. I want to see the dark band, so I drew on it here. And the outer borders. So I'm just showing you, I would not normally, when I would QC the MRI, I would not do this, but just to show you what I'm looking for. I'm drawing it a little bit messy, but yes, I think all the borders are clearly visible. So now I will go a little bit further anterior. So here again, the dark band is visible. And all the other boundaries are also quite clear. I'm doing it a little bit quick. But yeah, so I think this looks good. And I would, of course, kind of go through the image and look on every slice if I can see it. And if I see it on all or most of the slices, I would say it's included. So this image looks fine to me. So now I will show you another image. So here you can maybe see a bit of noise. And it's a bit harder to see, for example, the dark band in the hippocampus. But for example, this slice, I can see it. I can see it. So that's okay, I guess. I always like to also go further anterior because there it's often a little bit more fuzzy. But I think I see still most of it. It's not great, but I see most of it. What is a bit of a bigger issue here are these, I hope you can see that, these lines, these motion artifacts, which happens a lot with these T2 scans. So that becomes a bit harder than to tell where the boundary is. So just based on that, I wouldn't actually exclude it straight away. And the reason for that is I'll actually come back to that later in the tutorial, but I think there's some way to get around that. But if you just have the T2 and this is what it looks like, then maybe you need to exclude at least the cortical regions here. But I mean, then as well, it's quite quite fussy here. It's hard to tell exactly where the border is. So I would go through the slices, and if it's really hard to tell the dark band on a number of slices, I would maybe exclude as well. So it's generally a little bit better in the hippocampal body, but yeah. So this is a bit of a borderline case for the hippocampus, I would say. It's not great. So then I will show a third example. And I hope you see here, it's super noisy. It's a lot of motion artifacts. It's hard to tell anything within the hippocampus, but also see in general. It's hard to see the borders. So this one would be a definite exclusion for me. All right, so I'll go back to the PowerPoint. So then I generally just do go for binary decision, include or exclude, but it could be useful to give a rating because the image quality is of course related to segmentation quality, and segmentation quality can affect your results. But a rating is also a little bit subjective, so it's good to keep that in mind. So this is the rating that's used at 10. So a rating of 0 is when you really have a terrible image and almost nothing is visible. A rating of 1 would be if you have almost no contrast. It's not a good image, but it's of course a little bit better than 0, but both 0 and 1 would mean exclude. For 2 is if you see all boundaries that you need, but it's quite a noisy image. For example, the second example that I just showed in ITK Snap would maybe be a 2, maybe be a 1. Then rating 3 is if you all see all the borders that you need. It's not a perfect image, and then 4 would be like a really crisp, beautiful image. But I mean, yeah, it's of course a bit questionable whether certain cases, it's subjective whether certain cases would be 3 or 4. So that's a limitation, but perhaps for what you would need it for, that doesn't matter. And then another thing to maybe note down is the angulation of the hippocampus in the sagittal plane. So the image is supposed to be acquired perpendicular to the long axis of the hippocampus, but that doesn't always happen. And this could potentially affect segmentation quality, but I have never seen any evidence for that. So I don't know if that's the case, but it could be good to just note it down anyways. So what you can, the way you can look at it is, for example, in this example, so the T2 is a bit fuzzy, but helps to also see the segmentation. I hope you can see that it's a straight line. So that means that the image is acquired perpendicular to the long axis of the hippocampus. And then in this example, the hippocampus is actually at a slight angle. So for this case, you would maybe need to write something down that it's not straight. So then, as I already mentioned, there are multiple atlases, but I will talk about 2 of them today. The PMC is the original atlas and the ABC is the newer atlas. So if you're starting a new study, which atlas should you use? And I don't really have a clear answer. I think the hippocampal subfields protocol and the ABC atlas follows recent knowledge on anatomy and is therefore likely more valid. But the protocol is more complicated and therefore slightly less reliable for CA1 and subiculum. At the same time, actually, CA2 and 3 are a little bit bigger and also a little bit more reliable. So maybe that could really depend on your research question. And for the cortical regions, the PMC atlas has been quite useful. So it has shown to be quite useful, whereas the ABC atlas has not been used in practice as much. So these are just some considerations when you will want to choose one of these atlases.
Laura, do you want to mention about the additional tail, which might be a consideration, because you have to have a plan for how to deal with that for the ABC atlas.
Yes, and the ABC atlas is different in that it doesn't segment subfields until the end. It has a tail label at the end. So it requires some thought on how you would handle that. Do you somehow go vary for it for your analyses? Yeah, it's a bit uncertain how to deal with that, because it's the tail labels based, the start of the tail is based on an external landmark, so that could affect your how much of the hippocampus is labeled in subfields versus tail. And I think in general, it's good to mention that these atlases are in older adults with and without cognitive impairments. So that's, of course, also a consideration when you choose an atlas. So for both atlases, I'll talk a little bit about the kind of the smaller typical errors, which are negligible, some larger common errors, and some other errors that I found. And I'll go through the process of checking the segmentation in the screenshots, then in ITK Snap and the editing process. So the labels, and this is the PMC atlas, which is the one that I'll start with. So there are hippocampal subfields labels of interest. So that's CA1, dentate gyrus, subiculum, CA2 and 3. And the cortical regions, entorhinal cortex, BA35 and 36, and pericampal cortex. And then in this atlas, there are two miscellaneous labels in light green and light orange, and we're not interested in those, of course. If there's errors in segmentation, that really doesn't matter. I just want to point out colors can be different in different atlases, so don't pay too much attention to the colors. So then I always start looking at the screenshots, and just to orient you, the first 5 are coronal sections, and then the last 2 are sagittal ones. And it's good to kind of check the first and the second, the T2 and the T1 for registration accuracy. And a way to do that is, for example, to look at the grid, and you see the 2 arrows here. So this is a cross section of the grid, and you can see it's perfectly at the border of this cortex in both images. So that looks like a good alignment. And this is an example of another one where you see the crosshairs at the border of the hippocampus. So in general, I would say this is very well aligned. And I have to say that this is generally not an issue. I couldn't even find an example where it was misregistered, but in general, I think it's good to check anyway. And then in the screenshots, I would look for the general overlap of visible borders with the segmentation. Just point them out. On the top here, you see the blue, in blue, the borders that we're looking for. And then at the bottom, I overlay them at the segmentation. And then here's a zoom in of that. So I think it looks quite reasonable. It's of course not perfect, but it's an automated segmentation. And of course, it's also my hand drawings, which are, to be honest, not great. So that also plays a role there. But I think the borders are quite well aligned with the blue line. So then the other thing is, similar as for T1-ASHS, I would not really focus on the borders between the subfields. So between pink and red, for example, only dentate gyrus and the other, of course, because that's determined by the dark band, but none of the other subfield borders I would pay too much attention to unless you really know the segmentation protocol and want to do very fine-grained QC, but otherwise I would ignore those borders. So then one thing that can happen is partial coverage. So what you see here is in the sagittal plane, these sagittal screenshots are very small, and you see that the labels are right up to the edge, whereas normally you would have a little bit of space on both ends of the sagittal screenshot. So that could indicate a problem. So I want to show you this example in ITK Snap. All right. So if I scroll through it, the image actually stops here. I cannot scroll any further. And then if I look in the sagittal plane, you can see that it stops right here. There's only a small portion of the MTL included in this image. So this would be, of course, a problem and would mean that you have to exclude this case. Here I show actually another example, which is not as dramatic, but what you can see in the sagittal plane is that it's cut off right at the border of the segmentation. So that for me would be a reason to just check the image in ITK Snap. So I'm gonna do that now. All right, so I scroll through this here to the end, what you can see is I cannot scroll any further, and there's still some label in here in the last slice. Having said that, it's already getting smaller. So I think maybe we're missing one slice where there should be some hippocampus, but I think that's it. So in that sense, it's only one slice. I would say this is still fine. I would not exclude this case. Okay, so then I want to go over some small typical errors, and they're actually very similar to T1-ASHS. So there can be these small segmentation errors, and I hope you can see it where there's some scattered voxels from one label that occur in another label. That's generally at transition slides, and that's really, they're just often small errors, and that's not really the problem. From time to time, you see that a vessel is included in the segmentation. So as long as that's not on too many slices, then it generally is not, that's not a problem. The lateral end of the BA36 often looks a little bit missegmented. Again, I think that's a small error and you can ignore that. Cysts are sometimes over-segmented, but as they are very small, I would also say that's not really a problem. And then from time to time, you see a gap in the segmentation. This often occurs, of course, when there's a vein or vessel that is pressing against the cortex. But it can also occur in other places. But that's such a small missing piece of the label that it's really not a problem. So in general, I would say identify these small typical errors and then ignore them. So that's what you need to do when you get familiar with your data set, to see what kind of errors, small errors it has, and then just ignore them and look for kind of bigger errors. So another thing that happens is a bit of missegmentation in the hippocampal head. So I will zoom in here. So what I'm looking for here is that it should be continuous, this red label, and it's not. So I want to show you an example of this. Okay. So this is the slice that we just saw. So if I look for the border, you see that I'm missing a little bit of the red label here. So that's one slide. If I then go to the next one, let's say it's approximately here. So that should have been included. So that's another error. I think the next slide actually looks much better. And then if I go to the previous one, it also looks much better. So maybe this should have been included. But that means that only on 2 slides, there's a little bit of an error. So I think that's too little to really be concerned. So I would not exclude this case for this reason. And I think in general, that's the case. So this error doesn't happen always, but it happens in some of the cases, but it's generally not really a big deal. And I think one of the reasons why this happens is at this point, if you check post-mortem imaging, there's actually an interruption of the dark band. So it's normally it's connected, but here there's actually gray matter in between. So CA3 from the lower, there's CA3 lower in the dentate gyrus that's then connected with the top part. So I think it makes sense that the segmentation method is kind of making a mistake there, because the dark band is not quite as clear and sometimes not even there. So that, of course, would cause some problems. And again, as I mentioned, this is not the case in all examples. So in this case, it's completely fine. So it happens, but I think in general, it's not a big problem. What is a bigger problem is the systematic undersegmentation of CA2 and 3, which I think it happens in most of the cases. So that would be, there should be a green and a yellow label here, but there's not. So I would recommend actually to not use CA2 and CA3 labels in the PMC atlas, or combine it with CA1 to create a CA label. But that, of course, really depends on your research question. So then I want to first show you a good example. So here, the screenshot. So here I see the borders very nicely in both the MRI, and then when I overlay them on the segmentation, that looks good. And I show you here one in a more anterior location. And if I show a bigger slide, you can see hopefully that the borders align quite nicely with the segmentation borders. There's a little bit of an error, but again, as I mentioned, there are always some errors in an automated segmentation method. All right, so then I move on to 3 larger common errors. So one of them we've actually also seen for T1-ASHS is there's hippocampus label in the ventricle, often also including choroid plexus. So I hope you can see some of these incorrect voxels in the ventricle here. And this is a common error in cases with more atrophic hippocampi. So you can imagine if you would exclude all these cases, you could potentially have a bias in your data set in the end. So again, what do you do in this case? I would say open in ITK Snap, scroll through the image, turning segmentation on and off, and focus on the overlap of the segmentation borders with the borders observable on MRI. Only focus on the subregion for which you identified the potential error in the screenshots. Determine a rule for in or exclusion, such as a significant error on a certain number of slices. And again, there's no need to focus on any of the other borders between subfields unless you're very familiar with the protocol. I want to do very fine-grained QC. And then if you edit, only edit the subregion for which you identified a significant error. And the reason for that is that you're also not editing any other cases. So if you don't flag a case, you wouldn't edit any other segmentation mistake. So you don't want to do that in any of the cases, just where the error is too big. And you only want to edit on the slices on which you identified the error. So I want to now show this example. I hope that makes sense. So you only want to edit the thing that you flagged, because if you edit the whole image, you would have one beautifully segmented image versus other images that you thought were good enough based on the screenshots, which would have these smaller errors. So you would create an inconsistency in your data set, which I don't think is good. And also it's probably not feasible to go that far. So here, this label is incorrect. And I see one here, so that would be a second slide, and 3 and 4. So I see some scattered voxels in 4 slices. I have to say this is a little bit of a borderline case for me, but since this cluster of voxels is a little bit bigger, I would say maybe either exclude or edit. And to be honest, I think I would just edit just because it's so easy to do. So you would just use the clear label, go over it in each of the slices. So that takes, honestly, generally that takes less than a minute and you're already done. So it would be a bit of a shame to exclude this case just because of those voxels. Okay. So potential rule for in or exclusion could be exclude if the label outside the hippocampus consists of 5 or more voxels on 4 or more slices. So that would be, this is just an example. You don't need to do this, but this is just a way in which you can make the same decision for this type of error in all your images or your subjects. So then the second common error, and we also saw this again in T1-ASHS, is the lateral undersegmentation of CA. And sometimes this is adjacent to a cyst, and I indicated them with the red arrows here. But I also show here a zoom in where the black line indicates where the border should have been. So I will show you this one now in ITK Snap. Okay. All right, so Yes, so this is the first slice where you see this happen. I hope you can see this, but this should have had a red label. This should have had a red label, and so on. And this happens on a number of slices. So this would be the last one with a little bit of a smaller error. So that would be 1, 2, 3, 4, 5, 6. So there are 6 slices in which there is an error. So I think that's probably too big of an error. So I would either exclude or edit. And the editing in this case would also be quite easy. So on each slice on which you saw that there was a mistake, I would just add the red label in. So it's not actually super complicated. So you would do the same thing on all the other slices. So I won't do that now, but just to give you an example. So for example, you can exclude if a significant portion of the CA label or labels is missing on 5 or more coronal slices. And for T1-ASHS, we actually did this on the more on the sagittal plane, but since it's so fuzzy, I think it might be easier just to check this on the coronal plane. But of course, if you feel very comfortable with the sagittal plane, you can also come up with a rule for the sagittal plane. So here's another example, and it's indicated here by the red arrow, but it's, I would say, quite subtle, but you can see it here. And this is actually a common error in cases where you have a more fuller, healthier hippocampus that touch the ventricle wall. So again, if you would exclude all these cases, that would cause perhaps a bias in your final study population. So again, I want to show this example. So I think this was the slice that we just saw. So should have included a little bit more, but it's a kind of a minor error. Maybe here a little bit more. And here it's actually fine. And I want to point out that we're looking for this darker line, which is the alveus and the outer border of the hippocampus. On the other end, there are kind of voxels with the same intensity as the gray matter, but I think that's because of partial voluming, or maybe it's choroid plexus that's there. That could also happen, but yeah, we're looking for this darker line. So I see it's a small error on 2 slices, and then if I follow the darker line here, maybe a 3rd slice, and then here it's actually fine, I would say. I didn't draw that very cleanly. All right, let me do that again. Yeah, so I see a very small error, maybe on 3 slices. So here I wouldn't edit, I wouldn't do anything. I would just include this case. All right, and then the 3rd error that is very common is generally due to motion effects, which are motion artifacts which lead to missegmentation of the cortical regions. And I think it might be too small. So I have a zoom in here. So these lines, again, you can see those cause potentially segmentation artifacts. And of course, motion is more common in certain populations, such as dementia patients, but for example, also in children. So again, this could be an error that can happen more in one population or one group versus the other. So I will now show you this example. And here I'm actually gonna load the MP range as well. So the T1 weighted image. Okay. And what I want to do is make it a little bit brighter. All right. I think here I'm just going to focus on the entorhinal cortex. So what we see are these lines that makes it quite hard to determine the border with the white matter. But if you have a T1, can be helpful to see if you can use that one. And I'm gonna play with the contrast a little bit. So I think the border is here. And what you see actually is that the entorhinal segmentation is quite undersegmented in this slice. Of course, it is important that the T2 and the T1 are very well aligned, but I think in this example, that is the case. So it's quite well aligned for both images. So if we go then to the previous slice, again, if I kind of try to find the border on the T1, I will just cross here. So yeah, could be a little bit bigger on this end. Yes, okay. But it's definitely undersegmented again. And then if I go to the next slice, so again, it's undersegmented. So this is already 3 slices. So I think that's quite a lot. It's also quite a lot undersegmented. So I would actually either exclude or edit this case. And then if you would edit, I would again try and see if you can get some help out of the T1 image. So I would include it here and have the entorhinal over the clear label. So if you say complete and accept, this would be the accurate segmentation. So you would do that on all slices on which you see the problem. Okay. So yeah, so it can be useful for this particular artifact and segmentation error to check the quality of the segmentation of both the T2 and the T1, as the T1 is generally less sensitive to these motion artifacts. And that is also the reason that if you just motion artifacts in these cortical region is why I wouldn't necessarily exclude the case, but I'd rather check the segmentation together with the T1 if you have it to see if it's good enough. But if you don't have the T1, you might maybe want to exclude the cortical regions just because it's so hard to tell the borders when you have these lining artifacts in there. All right, so then I have one other error that I've noticed over the years, and that is over-segmentation of BF35 and or 36 when you have a very big collateral sulcus. This is generally the case in subjects with a lot of atrophy. And I just wanted to give a bigger example here. So it's the orange line that should have been the sulcus label or the miscellaneous label, but it's completely filled with BF36. So that, of course, is a problem. And you can actually also in the sagittal plane see that all this CSF, the lighter blue, should have been another label and not the BF36 label. So you would either have to exclude or edit this case if you can. So then I want to go to the ABC atlas. I will cover kind of the same topics, and actually the larger errors, the larger common errors are the same. Actually, the small typical errors are also the same. And the process of checking the screenshots, ITK snap, the editing process is all the same. So I won't spend too much time on that. So again, the same, more or less the same regions of interest. Hormone is 1, 2, 3, subiculum, dentate gyrus, and as Sandy already mentioned, there's a TIL label here. And dependent on your analysis, that could be something you're interested in, or you could put that under the regions of not of interest. And then there's again the cortical regions, the entorhinal, Bowman area 35 and 36, and hippocampal cortex. And unfortunately, the colors are different from the previous atlas. So then the small typical errors are the same as T1-ASHS, PMC-ASHS. So again, you can have these scattered voxels from a label from an adjacent slide coming through, not a problem. Over segmentation over vessels, lateral BF36 is a bit missegmented. Sometimes The cysts are oversegmented, but I have to say that that is actually less common in this atlas and some potential undersegmentation. Again, just want to identify these kind of errors and then ignore them. So I want to start again with a good segmentation. So here I show the outline of what I'm interested in and overlay them on the segmentation. And I do that again for a more anterior slice. And then I show the zoom ins, and I hope you agree that the blue lines nicely align with the outlines of the different subregions. This superior dentate-gyrus error I have seen a little bit less. It might be less of an issue in this atlas, and this is perhaps since we now include the dark band in the subiculum and TA label, so maybe that fixed that problem, but that's just a hypothesis from me. So in the PMC atlas, the SRM is actually in the dentate-gyrus. And then the other thing is that the CA2-3 segmentation generally looks quite good. So that issue of undersegmentation is actually not a problem for this atlas. This is likely due because in the protocol we made CA2 and 3 much bigger. So for this atlas, don't just exclude CA2, 3 for all cases, only when you identify significant error. And then the other thing is here is an example with a very big collateral sulcus, and the segmentation is actually correct. So it seems that this is potentially less of an error, again, with this newer atlas, but I'm a little bit less certain of that. So then for this, I actually found a total failure. I hope you can see that. This is not good. So either discard or run again, because clearly something went wrong for this case. And this is not specific to the ABC atlas. That could happen to any ASHS atlas, of course. So then the larger common errors for the ABC atlas are actually the same. So here is an example where there's the hippocampus label in the ventricle or the choroid plexus. Again, more common in cases with atrophic hippocampi, and I want to show you this example as well. And I'm actually getting to the end of the tutorial as well. All right, so you can see it here. These voxels shouldn't be there, and it's on, if I count correctly, on 7 slices. So I would either exclude or edit, like I showed you before. Oh,
I mentioned something real quick, Laura, about this particular error. So this is one of the things that hopefully will soon be taken care of, as there is an effort to try to provide topologically correct segmentation, and with the notion of using actually white matter and CSF labels. So that's hopefully not going to be an issue going forward.
Oh, that's excellent. Okay, great. Yeah. So yes, hopefully this will not be an issue in the future, but maybe still good to keep a lookout for this one. And again, if you want to edit, it's generally less than a minute. So
it's pretty easy, yeah. So.
Very easily fixed. All right. And then again, you could use the same rule as I said before, but again, this is just an example. You can come up with your own rule for your own data set. So then again, the lateral undersegmentation of the CA labels is also a common error in this atlas. And again, I want to show the zoom in, and where the border should have been is indicated by the black lines. Again, more common with healthier hippocampi. And this is the last example that I want to show in ITK Snap. Okay. Yeah, so as soon as I open it, I hope you can see that this is this portion is missing. If I go one further, that's about the same thing, and a little bit on this slice, I would say. And then if I go back, It's missing here. It's missing here. So I don't know how many slices that was, but that was quite a lot. It's even here, I would say these are some digitations. So it's still missing there. So it's 1, 2, 3, 4, 5, 6, 7, 8. 8 slices. Not all of them super severe, but the most of them have a big missing label. So I would either exclude or correct. So correction is a little bit more complicated than with the other atlas, but there are certain slices, and that's how I would start if I would do this. I would recommend just, there's red label on this end and on this end, so it would make sense to add in the red label in the middle here. So that would be an easy slice to fix. The same here. Since there's only a red label here, it makes sense to add that. So this slice would be a bit harder because there's red and yellow, so I'll skip over that. I'll skip over this one. But then this one is, it maybe looks more complicated, but it's not so hard. So the border in this atlas is done perpendicular to the CA cortex. So it's a little bit of a tilted line here. And then I can add in CA2 here, and then a little bit of CA3. And here as well. So kind of looks like not too much, it's not too complicated to fill in some of these slices at least. But if I go back, then this slice was more difficult than this one. So of course, for this one, you can at least add the red label here. That's, I know for sure. And then the yellow label, and you would just have to fill in this piece. And since the CA2 label is missing, and it's generally of this size, I'm guessing the biggest portion of this this gap is CA2, but that I would recommend reading then the protocol and filling it in. I would not recommend changing anything of the label that was already there. So I would keep it as is, but just add the label according to the protocol as good as possible. And if I remember correctly, CA2 is supposed to start 1 voxel over from the edge of the blue or the dentate gyrus. So then CA2 would at least have to start here. But then the question is, how far does it go that way? And in this example, we at least see some of the borders or some indication where CA2 should be. So at least there. And at least red should be here. And then yellow should be here. So it's honestly, it's only these 2 slices that are a little bit more complicated. And I would recommend just reading the protocol and then filling it in. And then again, even if you're a little bit uncertain, we're really talking about just a few voxels here and there. So even if you do it, so to say, incorrect, it's not really going to be a big issue. So yeah, don't overthink it. I would start with the slices where it's easy, you're really certain, and then generally end up with maybe 1 or 2 slices where you have to look at the protocol and maybe think a little bit more. All right. And then again, this was the potential rule for inner exclusion that I proposed, but again, you can completely decide for yourself. And actually, in this case, we added the CA1 label, so the red label, and found out that 7% of CA1 was missing in the original segmentation. And if you do crop comparison, 7% is often much more than you would find. So 7% is really a big deal. So it's important to either add it or exclude. And that could be a general thing to do. If you're uncertain if your error is big or not, you can edit the case and then calculate the difference to see if this is really a big error or something very small. Like the difference is less than 1%, then maybe it doesn't make sense to do the editing or the exclusion. But if it's 7%, then it's of course important to do something about it. And then the third example again is when you have motion artifacts, which leads to missegmentation of the cortical regions. And what I have here is actually quite a a bad image, so I would probably exclude this image, but I did want to kind of show this segmentation just to, and I want to show zoom in here just to see what these motion artifacts can do to your segmentation. So you think you maybe see the borders, but in reality, these lighter motion artifact lines completely fool the method, the automated method, and make put an ERC label over there, and then it stops, and then it continues there. So it's really something funky going on. This is not biologically plausible that ERC is located there and then never not there and then there again. So yeah, I hope this is a nice example to show that this is an important issue and you need to be really careful about it. So then I identified a few other small errors, or well, big errors, but these are not as common. So here you see kind of a white matter lesion in the hippocampal white matter, which completely messes up the segmentation. So you would either have to exclude or edit this case. Found another kind of funky error here, and it's maybe hard to see, so I'll show the zoom in where there's weird places, some stuff missing. So again, here you would have to check in ITK Snap to see how big the error is, and then either edit or exclude. And then I found another third one, and there's something missing there. And I hope you see that, because it should have some yellow and green labels over here, and this looks kind of flat, like you want to see a bit more of a rounded hippocampus there. Not always the case, but often the case. So if you zoom in, the black lines again are where there's something missing. So again, be good to go in ITK Snap, check how big the error is, and then either include, exclude, or edit, dependent on the severity of the error. So I just want to show these other ones quickly, so you are just be on the lookout for other types of errors. I just mentioned the most common ones that I've encountered, but there are, of course, other errors that can occur. So in summary, start with QC of the MRI, then of the screenshot, then in ITK Snap if needed, and editing if needed. And in very large samples, at least QC a subset of the data to get a sense of the data quality, type of errors, or bias in the errors. It's good to familiarize yourself with the data before starting QC, decide on rules for in and exclusion and editing beforehand, assess whether certain types of errors occur more in certain population and can create a bias when excluding. When doing QC with multiple people, go over a number of cases together and perhaps even discuss difficult cases at the end, and write down the things you observed during QC. And then I pointed out 3 common errors that I found for T2-ASHS. One is the label outside the hippocampus in the ventricle. One is lateral undersegmentation of CA. And one is missegmentation of the cortical regions due to motion. But note that different errors can occur in different atlases and different target populations. So check your data. And these are, again, I want to say I've mostly experienced with older adults with and without cognitive impairment. So it's possible that with a different atlas in a, for example, a population of children, you would get very different errors. So keep that in mind. But I do think some of the general points are applicable to other QC of automated segmentations of other atlases and other field strengths, such as 7T. And then I know this was a lot. So thank you for listening. And I want to stop share and see if there's any questions.
So Laura, one thing I think it might be helpful to comment about is the different MRI sequences vis-a-vis the choice of atlas. If you had any guidance on that, for example, the 2 millimeter thick sequence versus the ABC 1.2 millimeter thick sequence. And I'll just start off by saying one thing which not everybody might be aware about. If people are using ADNI data, the quality rating of the images, at least that Laura talked about, are being made available by us on the ADNI website, as well as the volumetric data. So anybody can use that. So please, I would like you to comment on that, sequence versus atlas issue.
Right. Right, that's a good point. Yeah, so the PMC atlas is based on images with 2 millimeter slice thickness and the ABC atlas with 1.2 millimeter slice thickness. So that dependent on the slice thickness and your in your target population, that could be a consideration when you pick an atlas. Having said that, I have actually seen that the ABC atlas with the thinner slices works quite well also on at least some data with thicker slices. So it doesn't mean that you cannot use it on other on sequences with kind of slightly different image resolution, but it is a consideration, of course, and then it would probably be good to just run it on, like, say 30 cases and see what it looks like and how it works. Are there any other questions? All right.
That's great. Thank you.